Hi, I'm Pat Koszczaba, and today we will talk about a very controversial design pattern. It's time to meet the singleton. This is one of those design patterns that are loved by ones and hated by others. Some say it is absolutely useless, in fact it is an anti-pattern. Others say that it is very powerful and very useful. I consider the truth to be somewhere in the middle. The singleton is a class capable of providing a single instance of itself. Instead of having a public constructor and creating a new instance each time a client needs an object of its type, it will simply use the getInstance public method, create, if needed, and only if needed, a new instance of itself and return that instance. There are some more concrete and also some more vague situations when a singleton can be useful. I will mention logging, service locators, or some client-side user interfaces. But if you look up on the internet, you will find that singletons are used also as facades in applications when there is only a single entry point to the application or to the module, and keeping a facade a single and constant object throughout the life cycle of the current run of the application is a good idea. Then it can be also used in conjunction with an abstract factory, builders or prototypes. State objects can also be singletons. The big advantage is the possibility of lazy loading. You can create a singleton only when the first call to its getInstance is happening, and all the subsequent calls will be to this created instance. No new instances will ever be made. This is very useful when it is expensive to create such an object. So, for example, if you have a service providing information from a slow source, you may consider using a singleton. However, it's a pattern that is very easy to implement, and pattern abuse is very easy to achieve. Be very careful, because it pollutes the global namespace, and each of its users creates a direct dependency to the singleton class, thus making testing more difficult. That's why you will see very few singleton objects in test-driven applications. So I recommend you to take your time to learn this pattern because it's very powerful, but use it only when absolutely needed. For our example, a singleton will be a discount provider, and the client of such a singleton will be a price calculator. The price calculator will have a function compute. It will have a parameter a product. At some point, this method will want to return a price minus a discount. To do so, it has to obtain both values. Obtaining price should be simple. We can just ask our product. However, obtaining the discount as value is based on a discount as a percentage. Let's say we do a simple computation. Discount as value equals price multiplied by a discount as percentage. However, there have to be some kind of object providing this discount as percent. Such an object would be a discount provider. If we would have a complicated application, providing discount may be difficult and may require long and heavy calculations. So, our architect and the fellow developers decided that we use a singleton object in our webshop application to provide the discounts. This singleton is the discount provider. and will obtain a new instance by calling the getInstance on it. This method is both public and static. After we have a discount provider, we will ask it for a discount as percentage, and it will be capable of providing it based on our product's ID. The next step is to implement our Singleton discount provider. The most distinctive feature of a Singleton is that its constructor is private. This means no one from the outside can create a new instance of such a class. In the real world, here would be some complicated initialization logic. However, any class has to be instantiated at least once, so that there is an object that can do all the stuff implemented in the class. For that, we will have a private static instance, a variable initially null. Then we will have a static getInstance function. This function will check our instance state. And if we don't have an already instantiated object of ourselves, we will call our private constructor. As a final step, the getInstance method will return the object contained in the variable called instance. So far, we provided all the mechanism to create a discount provider from the outside, or to reuse an already created one. However, we still don't have any logic. In our price calculator, we called getDiscount4. This is a dynamically called method on a real discount provider object. That's why we will implement it as a usual method and not a static one. It will have a parameter, a product, and in the real world it would return the discounted price as percentage, but for our example we will just simply return 30. In fact, this logic we did not implement is the whole reason we created a singleton. Sometimes getting a discount for a product can be very difficult. Or creating a list of discounts can take so long that you don't want to do it for each caller who needs a discount for a product. You want to do it only once, create the object, create all the information you need, and then just provide using this single instance whatever the clients need. Also, the clients will have to know this and ask for a new instance of such a discount provider. After they have the instance, they can use it to calculate or to do whatever they need with the discount as a percentage. From the implementation point of view, this is all the Singleton pattern is about. Provide an instance which is unique, then do all the stuff that the class has to do. I will stop here today, and the next time we will talk about another way to achieve singularity in your application. We will study another design pattern, which is like a hidden singleton, called the monostate. Bye bye.